In this video we have the integral of 3x cubed minus 2 over x squared plus 4. Now the integrand is a rational expression. Let's go ahead and divide to see what we get. So we do a long division and take the numerator divided by the denominator. So we got x squared into the first term, 3x cubed, will give us a 3x. Then multiply times the divisor. This will give us a 3x cubed. Then 3x times 4 will give us a plus 12x. Let's move the minus 2 over here. And then we subtract here. 3x cubed minus 3x cubed gives me 0. And here we have a 0 here. Minus 12x will give us a minus 12x. And 0 from minus 2 will give us a minus 2. And that's as far as we can go here, because the degree of the remainder is less than the degree of the divisor. So let me rewrite this over here then. This becomes the integral of 3x is a partial quotient, and then it's a plus. Got the remainder here over the divisor, so this will be minus 12x minus 2. And that's over x squared plus 4. So then we can integrate 3x very easily with respect to x. This one over here is still a rational expression. I would not try partial fractions here though. I'm going to do this. Don't have to do it. I could just do it term by term here, but I'm going to separate these into 3 integrals. So this would be the integral of 3x with respect to x. And then this would be a plus here. And I'll break this up into minus 12x over x squared plus 4 and a minus 2 over x squared plus 4. So this integral here, I have minus 12x. And that's over x squared plus 4. And then again I'll have a plus here. And this will be the integral of minus 2 over x squared plus 4. So now I have 3 integrals here. The first one, no problem. Integral of 3x with respect to x. This is a 1 here, so let's add 1 to that. That's a 2 and then divide. So this first integral then will just give me a 3/2 x squared. Now notice here for this one here, got a minus 12x over x squared plus 4. Now notice the derivative of x squared plus 4 gives me 2x. And I got an x up here. The constant is no issue. I can always factor that out. So I would do a u substitution here with u equal to x squared plus 4. Or you can do this mentally if you know what you're doing here. So I'm just going to say the integral of this. So mentally I'm doing this. You can do it and show the work if you want, if your instructor wants you to do that. But up here I'm just going to say it's x squared, u is equal to x squared plus 4, and then du would equal to 2x. So du is 2x dx. Notice here, replacing the x dx, right here we got an x dx by du over 2. This would just give us a minus 6, and this would be du. The 2 divided the minus 12. So this would come out to minus 6 natural log. Absolute value, but x squared plus 4 can't be negative, so I don't need the absolute value here. I just write this as natural log of x squared plus 4. And notice you can easily check this because the derivative of this would be x squared plus 4 in the denominator, and then the derivative of x squared plus 4 in the numerator, that would be 2x. But I have a minus 6 here, so it gives me a minus 12x. That one checks out. And on this one right here, if I factor out the constant, well, let me do it this way. I have a formula. I've used this before in other videos. If you have the integral of du over a squared plus u squared. The integral of this is 1 over a, arctangent of u over a. And then it has a constant of integration. So for this one here, I can factor out the -2. And then you're just looking at dx over x squared plus 4. So the dx is the same thing as the du. So if I look then, after I factor the -2, I got dx over x squared plus 4. That's this over here. With x playing the role of u, and the 4 is the a squared. And 2 squared is 4. That tells me that a is 2. So the answer to this one using this formula over here then would be the coefficient, which in this case is -2, divided by a, but a is 2. And then it's arctangent of u over a. In our case, u is x and a is 2. So -2 over 2 So the final answer then is 3/2 of x squared minus 6 natural log of x squared plus 4 plus arctangent of x over 2 plus the constant of integration. Thanks for watching. We'll see you next time.